Well, thank you all for sticking around. We got one more presentation. I think it's going to be a good one. And let me see what I'm actually supposed to say here. Just as nature bats last, as evidenced by this wild winter and today's pretty wimpy atmospheric river, maybe, by our standards. Our final speaker will close out Recycling Update 2023 with a very interesting story about the startup that she co-founded with two other women she met at Carnegie Mellon University in Pittsburgh. The company, Refiberd, is leveraging technology to help sort out textiles for enhanced recovery and utility. The last thing I'm going to say is, I don't know if she's staying to go to the bar or if you're staying to go to the bar, but she and her co-founders also had a very interesting adventure about 10 days ago with Silicon Valley Bank. Sarika Bajaj is the co-founder and CEO of Refiberd, a seed stage startup that is tackling the textile waste challenge through novel technology that sorts textile waste by material for a range of recycling applications. Refiberd's material detection system involves using near-infrared radiation spectroscopy and artificial intelligence to be able to accurately detect multiple blends in textile waste, including traditionally problematic materials like spandex and nylon, as well as multi-layered garments and disruptors like zippers and buttons. Her presentation is entitled Textile Waste Sorting for Recycling with Refiberd. Sarika Bajaj.
Hi, everyone. Thank you so much for staying long enough to hear my talk. Let me see just if this is working all right. Blue button. There we go. Okay, thank you. Hi, everyone. My name is Sarika Bajaj. I'm the CEO and co-founder of Refiberd. As Steve mentioned, Refiberd is an early stage startup that has developed novel technology that really is designed to properly detect materials and in textile waste to enable recycling. And really the goal of our talk today is to get everyone a perspective into the issues that we're really dealing with as sorters, as sorting technology. What does recycling look like and what do we need help with? And then how do you actually help early stage startups in this space? What are some of the challenges that we're facing? So, no, maybe not. Is that working? Still. We're almost at the end, guys. It's okay. Okay, there we go. Thank you. So to start off the presentation, let's talk about what does textile waste actually look like? What do we look for in textile waste and where does it come from? So we kind of have three general categories. This is by no means comprehensive, but we're really talking about fabric yardage. So imagine large yards of textiles that are actually used to be cut, and then that's how we pattern make textile clothing. We're talking about scraps. So oftentimes like offcuts, which is, whatever has been cut around the pattern just gets kind of lumped together from the production process. Also somewhat in the textile scrap category is rags and rag creation. That happens a lot for industrial uses. And then also whole garments. And so this is, of course, like post-consumer, pre-consumer, maybe returns, three kind of categories that we look like. Each of them, we really try to break down on what material they are. So as Joanne mentioned, the real difficulty in textiles is the blends. It's the fact that you'll have so many material categories that's all blended together and you'll have like 5 blends in one single item, and that maybe even just be 2% of one, and that can cause enough contamination in the recycling process. So something that we look really carefully for. We also talk about is there any hardware present? So that's buttons, zips, seams, all of those will sometimes have to be hand processed out to really enable certain types of recycling. So it's really critical that we can see if it's there. And then of course, you're talking about general contamination. So there's mold, dirt, chemicals, anything else that can interfere in our process. We're also then talking about the location of waste. So one strong asterisk I want to put here is Refiberd really focuses on post-consumer waste. And there are certain categories like Joanne mentioned, which is maybe, like hospitality linens that has its own waste stream. We're talking about general textile waste. Really, we see it present in textile mills. So this is the offcuts, this is the yardage that they cut from whatever got purchased or is used in the production process that isn't being used anymore. That's one bucket. Then we're talking about brand warehouses. So you're talking about defective garments, but most commonly returns, as well as overproduction that never got sold. So this is like a whole garment that's completely intact and just no one got to use it. Thrift stores is where we start seeing the shift to post-consumer. And so that's something more like, when you or I actually give something to a Goodwill, generally you'll see more whole garments there, sometimes a little bit of fabric yardage, but that's not the main target. And then landfill is everything you can imagine, and so that's where it gets a lot messier. And of course, when you're talking about contamination as its own argument, landfill is of course some of the most challenging, right? Because then you're talking about the most contamination possible with mold, dirt, etc. When you're talking about what can actually be done with the textile waste and what's the priority order. So we always like to do resale, reuse first, right? That's as much as we can extend that. That's really helped by the thrift stores, by everyone who kind of really works on that process, and then repair to enable more resale and reuse, right? And there's some really great startups and really great companies that are working on that. Generally, after resale and repair happens, then we're talking about rag cutting. And so this is where people will cut down large pieces, like maybe the backs of a garment, and that can be used in industrial applications for, like different machines that need to sop up oil and stuff like that, further adding to our contamination. And then you're talking about textile to textile recycling. And we will definitely dive into what recycling looks like, because that's Refiberd's main focus. And then finally, you're talking about shredding and downcycling. And so this is something like housing insulation or other types of shoddy, sometimes even toilet paper. This is kind of the lowest, the fiber quality is the weakest at this stage, and we're basically extending it as much as we can. As we mentioned, textile to textile recycling is what we have been focusing on the last 3 years as what we really want to enable, but to some level, Refiberd's work on enabling all of these. And the reason we're focusing on this is, of course, because less than 1% of textiles today are actually recycled into new clothing. You're seeing about 20% in general be left to reuse, repair, cut into rags, downcycled, and then other 80% is basically directly landfilled or incinerated. Of that 80%, about 70% could actually be properly recycled if we just knew material. So let's talk about why material is so important. So there are two main segments in this recycling for textiles. There's mechanical recycling, where you have a large mechanical physical machine where you basically have a bunch of gears, for lack of a better word, that actually will open up fibers and blends in each garment and be able to reproduce that into new thread. Now, this really only works if you have a high purity input. And so cotton, for example, 100% or as close to 100% as you can get. Polyester, 100%. You really don't want to deal with other contaminations because that will physically mess up the mechanical machine. This also means like seams, everything like that just cannot enter that process. What's really good about mechanical recycling is that it's the oldest industry in this space and it's the most established, and so that's not to say mechanical recycling isn't great, it's just, it has its limits. Over the last 10 years, really what we've been seeing is the development of chemical recycling for textiles. And what that really looks like is people are using different chemicals to actually dissolve different fiber types. The main focus is in cotton and polyester. This is because of all textile production, cotton and polyester is 90% of really what we're looking at here. And then 10% some mix of nylon, spandex, everything else. The problem that these guys have is recyclers can handle cotton poly blends, but they can't deal with much contamination from other fiber types. And that's where nylon comes in, spandex comes in. If anyone actually were to look at the garments you guys are wearing on, we tend to like things that are stretchier, which makes a lot of sense as a consumer, but that means you have 5% spandex contamination or 2% spandex contamination, which all of a sudden, for many applications of chemical recycling, renders as unrecyclable. Now, when you're talking about how do we even get material for this input, what we really need is accuracy of material sorting. Like, can we see what is in the blend? Can we see the 1 to 2% of spandex contamination. And that really has been a struggle so far. And that is the main problem that Refiberd has come out and developed, is that we can get accurate detection. The other difficulty is with multi-layered garments. And so imagine you're wearing a blazer, the outside might be a nice wool, the inside's also a beautiful wool, but you have a spandex poly stuffing in the middle that has now all of a sudden, if it goes through the process, a recycler is going to be really unhappy because now you've just ruined their 1 ton recycling unit, which also means to a waste of chemical. And then we're also talking about detection of those contaminants, like we mentioned earlier, buttons, zips, anything that needs additional processing, we need to be able to know earlier on. And so this is what Refiberd does. So we've developed a really new technology using NIR spectroscopy, artificial intelligence to sort waste by material for recycling. That means a much higher accuracy rate than we've been seeing from other sorters. Many people in the industry so far have only been about 60% accurate, which isn't really good enough for those contamination detection that we talked about earlier. As well as you're talking about a much bigger range of materials, we can detect all of these garments. The real way we're able to do this is a clever application of artificial intelligence, to be honest. I mean, we are a team of engineers that more or less stumbled into this industry, and it's mostly because we realized we could remove noise that makes all of this sensor data a lot more usable. And so that's really how we got into this. We were founded in 2020. We are a COVID company, baby. But really what we've been working on is proving out that this technology is real, because this is a huge gain in terms of what's possible with sorting technology. So now this is the time to really work on sorting pilots. We're trying to figure out how we can engage with industry as much as possible, and how can we actually implement our sorting technologies and different techniques to make the difference that we always set out to make. Of course, there's lots of questions here on like best in business model, best form factor, and these are the conversations we're trying to have this year. So if you guys are free, please find me at the bar later if this is something relevant to you. But yeah, this is our information. Thank you so much for listening. Really appreciate it. Oh, I also do want to take a shout out for Joanne. She has been doing amazing work in this space. She had also talked to me actually 3 years ago when I was still a student before all of this had happened, and was a lot of the reason why we even started to exist. And so, yeah, really, really, really appreciate all of our work here.
Questions, people? You're fine. Sorry. It's good. There's questions at the end of the last. Nice.
Hey, so we hear chemical recycling and like red flashing lights go off, like warning, warning, warning.
Yep.
So when you're using chemicals to dissolve fibers, do you have a way to reuse those chemicals and also make sure that whatever you've dissolved is kind of disposed of or recycled as well in a proper manner? Thank you.
Yeah, that's a great question. So just to be clear, actually, so Refiberd itself, we're just on the sorting side. And so we work with these recyclers, including the mechanical and chemical recyclers, but we ourselves are not handling the chemicals, just as an asterisk. But for chemical recyclers, the ones that have been more successful over the last 100 years are seeing up to 99% reclamation in the chemicals they're using themselves. And they're highly incentivized to do so in this market, just because they need to get the cost of fibers really cheap, right? Really what we're talking about here to make recycling feasible in the textile industry is to make this cost competitive virgin. The chemicals needed to dissolve these fibers are very expensive. And so they really need to preserve every ounce and drop of that into their whole system. And so for the most part, they're pretty good. High asterisks there, which is that's not my actual industry. And so this is what I'm reading and talking and everything from them. Yeah, I will pause there. Good talk forever. Any other questions?
I have a question.
Oh, yeah.
Are you testing any prototypes? And if so, where? This is from Susan.
That's a great question. We have a functional prototype first pilot system actually based out of Oakland, California. That's where we are based out of. That's where our lab is. And that's where we would like to run more pilots. So again, if you are interested, I will keep pitching this. Sounds good.
Good afternoon. Fantastic presentation. Could you indicate what fibers you are actually determining with NIR?
Yeah, that's a great question. So we have a comprehensive list that we'll actually be publishing in the next couple months, which really shows the ranges of our technology. As a quick summary, what we're doing is cellulosics. And so for those who may not know, because you don't live this life that we live, it's a blend of anything that comes from a leaf, right? It's so cottons, linens, even rayons would all fall under that same cellulosic bucket. Then you're talking about poly, which is the other big one, and then spandex, nylon. And then you have some of like the weirder blends that come out of this. And then that's a question of like how much is actually identifiable. And so rayon sometimes we can do into cellulosic, we can do not separately, but it's about a different range of 15 different materials.
That might be it.
All right. Well, thank you guys so much. Really appreciate it.
All right. I just want to thank Sarika and all of our speakers today, and to all of you for coming out today under some challenging circumstances. I'm also doing a little wildcat. I want to shout out for Rebecca Jewell's effort on working on the program for her 10th year this year.